All right, number 36. Oh, this is an osmosis question. Let's talk about osmosis. This basically, so this question says, use two of the following four options, that's your options there, to fill in the two blanks in the statement that follows. So let's take a quick crash course in osmosis. In osmosis, only blank moves through a semi-permeable membrane into an area of blank concentration. So here's osmosis in a nutshell. We didn't talk at all about this. So imagine that this is just plain water. This is all just water in this cup, and then we put this membrane, or we divide the water right down the middle, and the membrane is permeable to water. So water can go back and forth across this membrane, but solutes cannot. So by solutes, let's say that we put some salt in here. So NaCl. Let's put some sodium chloride into this water, but let's only put it on this side of the membrane. Okay, so we put all this salt in here. So we've essentially got one side of this that is salty and the other side that is essentially not salty. Okay, so osmosis is the process where water will move across a semi-permeable membrane so that it basically tries to even out the saltiness of a solution. So really, what we're going to try to do, the water is going to try to make its way across this membrane to basically make this side less salty and try to equalize it with the other side. So basically, the answer here in osmosis, only solvent, which is water in this case. Osmosis always deals with water. In osmosis, only the water solvent moves through the membrane to an area of higher solute concentration. And so really what water is trying to do is just find a balance. It's trying to make both sides of the membrane about the same saltiness. Okay, so after this happens, the water level will be higher on one side than it is on the other, believe it or not. Okay, it's a major body function in your kidneys and stuff like that. It's kind of in the world of biochemistry, I would say. But that's osmosis in a nutshell. Okay. What are the only two products of a combustion reaction? So we're talking here about a combustion reaction where we have to assume that this is some sort of a hydrocarbon, like propane, like this is C3H8 is propane gas, and for that to burn, we've got to do that in oxygen. And this just goes back to the beginning of second trimester. The products of this recombine these atoms always into carbon dioxide and water. Okay, those are the products of a combustion reaction, on paper anyway. The reality is lots of other junk gets made, but on paper this is how it should be. Okay. Number 38, when strontium hydroxide reacts with hydrochloric acid, the products of the reaction are what? So this is an Arrhenius acid and base reaction. So here, remember that strontium hydroxide looks like this, SrOH2, and hydrochloric acid, HCl. This is some of the most recent stuff that we've done in class. So remember that Arrhenius acids and bases, that, an Arrhenius acid has the hydrogen and the Arrhenius base has the hydroxide. That's what we stressed in class. And remember, these are neutralization reactions, they're also double replacement reactions where the inside ions will join and the outside ions will join. So we're going to remember that we always make salt and water. Okay, those are always the products of a acid-base reaction in the Arrhenius model anyway. And so the water that we make is just HOH. That's the hydrogen ion and the hydroxide ion. We typically would write that as H2O, right? And then the salt that we form is actually going to be a combination of the positively charged strontium ions and the negatively charged chloride ions, and that is SrCl2. And remember, that 2 is there because of the oxidation state of strontium, and the oxidation state of chlorine is -1, so strontium does not get a subscript. Okay, so just remember, salt and water are always the products of an Arrhenius acid-base reaction. Okay, number 39. The above is a Bronsted-Lowry acid-base reaction. Okay, label each as either a Bronsted-Lowry acid, a base, the conjugate acid, or the conjugate base. So remember when we talked about this in class, we said that the Bronsted-Lowry acid is going to ultimately become the conjugate base. And the Bronsted-Lowry base is going to ultimately become the conjugate acid. Okay? And remember, the acid is the thing that is going to change by 1 hydrogen. Well, both of them do, but the acid is the chemical that loses the hydrogen, and the base is the chemical that gains the hydrogen. So it's all about just looking at what becomes what. And let's take this first one here. So this one becomes this, clearly, right? These two things are so similar that we can say that this, over the course of this reaction, becomes that. And let's see how they change. Well, the way that this changes is that hydrogen has essentially been donated to this water molecule, and that water molecule, H2O, becomes H3O, right? And so remember that the acid, the Bronsted-Lowry acid, is the one that gets rid of the hydrogen. The Bronsted-Lowry base is the one that accepts the hydrogen to become the products, which are the conjugates. So the base, H2O, becomes H3O. The base becomes the conjugate acid. I'm just going to label that Ca, conjugate acid. And the acid becomes the conjugate base. Conjugate base. Okay? All right. Remember also here, the Bronsted-Lowry acid and base, they're always reactants. And the conjugate acid and base are always the products. Okay, so you're never going to have a conjugate acid or base over here on the left. There, it's always on the right. Okay, number 40, X-ray technicians at the hospital wear aprons made of lead to shield themselves from X-rays. Don't know what that means. Just commit this to memory, guys. Even if you've probably had an X-ray where they've put lead aprons like around your chest or something like that. It's just lead is so densely packed. It's such a dense element that it has the ability to block some of those electromagnetic waves like X-rays. So lead is our go-to material for blocking out harmful X-rays. Okay.